Work and energy. Table of contents. We're going to start by defining what system means and environment. Then work, and the first energy we'll do is kinetic energy, energy of motion, gravitational potential energy, energy due to position, elastic potential energy, also due to position, then wrap it all up with the conservation of energy, and then two other interesting topics, gravitational potential energy as related to escape velocity, and then power. System and environment. The fundamental concept of energy was explained by Richard Feynman, a Nobel Prize-winning physicist. There is a fact, or if you wish, a law governing all natural phenomena that is known to date. There is no known exception to this law. It is exact so far as we know. This law is called the conservation of energy. It states that there is a certain quantity, which we call energy, that does not change in the manifold changes which nature undergoes. And this is from the Feynman Lectures on Physics, mainly Mechanics, Radiation and Heat, copyright 1963. The concept of energy is so fundamental, like space and time, that there is no real good definition of what it is. However, just like space and time, that doesn't stop us from doing very useful calculations with energy. Energy is related to motion and forces. It can be stored. It can be changed from one form to another, such as light to thermal energy, mechanical to thermal energy, gravitational potential energy to kinetic energy, and of course many others. It can be measured and compared, and it cannot be created or destroyed. In order to perform calculations with energy, physical boundaries need to be set. The physical boundaries are based on the system and the environment. A system is a small segment of the universe that will be considered in solving a specific problem, and we will erect a boundary around it. The environment is everything else outside the system boundary. The system can be a particle, a group of particles, an object, an area of space, and its size and shape is totally determined by how you want to solve the problem. So why are we defining a system and its environment? So we can make the problem solvable. By defining an appropriate system, we can isolate the forces and the matter that are within the system from the forces that act on the environment and the matter outside the environment. If the only forces are internal to the system and no matter crosses the boundary between system and environment, then there is no change in the energy of the system. External forces and matter moving across the boundary will change the energy of the system. Let's give some examples. The moon, up here, exerts a gravitational force on the Earth, so it must exert a force on every object on the Earth. Why then, when we work out the motion of a drop ball near the surface of the Earth, don't we need to take into account the effect of the moon's gravity? Or for that matter, the gravitational force from the sun and all the other planets, and three dots there mean, etc., etc. When we solve for the motion of a dropped ball, we only consider the gravitational pull of the Earth because the Earth's gravitational force on the ball is so much greater than the gravitational force of the moon and everything else on the ball that we can ignore everything but the ball and the Earth when solving the problem. So even though every object in the universe affects every other object in the universe, most of the effects on any one object are too tiny to care about. Often we can just consider one object or a small number of objects and ignore everything else. To solve problems, we divide the universe between what we want to study, that's over here, and this dashed line here is the boundary, and everything else. How's that for a technical word? And the whole box there is representing the universe. As we've said, a system may consist of one or more objects, and here we have two objects, or amount of material in a region of space. We put an imaginary boundary or picture frame around the system. Everything else, some or all of the universe outside the system boundary, is the environment. Couple more definitions now. First of all, systems can be closed or open. When a system is unaffected by anything in the environment, it is a closed system. And that's being represented by this solid box around our two objects. It's as if the system was in a universe by itself. Objects in it can't leave. No outside object can get in. No outside forces affect anything in it. Forces inside the system cannot affect anything in the environment. And finally, energy cannot be transferred in or out of the closed system. When a system can be affected by its environment, it is an open system. And that's here with the dashes. And here we have our two objects. One is moving out, and this object here is moving in. While we focus on the objects in the system, and that's why they're a different color from all these other objects, they are affected by the environment. Objects might be able to leave. Outside objects might get in. Some outside forces affect the objects in the system. Forces inside the system can affect the environment. And the key point, energy can be transferred into and out of our open system. Caution: sometimes a system is considered open even if a force is caused by an object within the physical boundaries of the system. So we're going to find a earth block system. Right here, we're going to connect it with a little wire there, and we have the earth over here. A tension force acting between those two connected blocks is internal and is considered a closed system. So here's our closed system. Now, how does that become an open system? Well, we're going to have a table here. And the interface between this and the two blocks has friction. And you can physically see, hopefully, that this table is within the boundaries of our earth block system. But the interface is not part of the defined earth block system. When we first defined the system, we didn't include that table. Therefore, the friction force is considered an external force leading to energy dissipation, and the earth block system is now considered an open system. We will elaborate on this later.